In this question, we have tan inverse 2 by 4 plus tan inverse 2 by 9 plus tan inverse 2 by 16 and so on till tan inverse 2 by n plus 1 whole squared, and this goes on till infinity, and we have to find the solution. Now here, this is the general term. So let us try to simplify this term. Tan inverse 2 by n plus 1 whole squared. So what we first of all do is we expand the denominator. So we write 1 plus n squared plus 2n. And in the numerator, we have 2. Now here, from these two terms, if we take n common, we have tan inverse 2 by 1 plus n into n plus 2. And if we change the numerator in the following format, which is n plus 2 minus n, here this term is now in the format where it can be written as tan inverse of n plus 2 minus tan inverse of n. So, if we write the first term T1, the first term is tan inverse 3 minus tan inverse 1. The second term is tan inverse 4 minus tan inverse 2. The third term is tan inverse 5 minus tan inverse 3, and so on. So let us take these three terms to the next page. So if we further write a couple of more terms, T4, we will have tan inverse 6 minus tan inverse 4, and so on. We get tan inverse of n plus 1 minus tan inverse of n minus 1. Then we have tan inverse of n plus 2 minus tan inverse of n. So if we add all these terms, you can very well see that we can cancel out these two terms, tan inverse 3. Then we can also cancel out tan inverse 4. And similarly, these terms will get cancelled out. And here also, these terms will get cancelled out in a similar manner. So we will be left with minus tan inverse 1 minus tan inverse 2. That is the second term from the first two terms and the first term from the last two terms. So eventually the entire sum, let us say if we represent it by S, would be equal to tan inverse of n plus 2 plus tan inverse of n plus 1 minus tan inverse of 1 minus tan inverse 2. Now as n goes to infinity, these two terms will go to pi by 2. So this becomes pi by 2. This term also becomes pi by 2. And we have S is equals to pi by 2 plus pi by 2 minus tan inverse 1 minus tan inverse 2. Now tan inverse 1 is pi by 4. So pi by 2 minus pi by 4 is pi by 4 plus pi by 2 minus tan inverse 2 becomes cot inverse 2. So we have the final answer as pi by 4 plus cot inverse 2, and that is the answer to this question. So if we look at the options, pi by 4 plus cot inverse 2 is given to us in option 2, and therefore option 2 is the correct choice.